Hi, today's topic is Land and its Resources, Part 2. We will continue from what we have learned earlier in Part 1. Let's have an overview. In today's topic, we will learn about the silicon compounds which exist as silica and silicate. Then, we will highlight the various uses of silicon compounds in our daily lives, such as glass, electronic chips, and construction materials. After that, we will examine calcium compounds, specifically calcium carbonate and its properties by doing some experiments. We will also look in detail at calcium oxide and calcium hydroxide by conducting our next experiment. We will also study the uses of calcium compounds such as limestone, marble, quicklime, slaked lime, and calcium carbonate in the construction industry. Then, we will also look at natural fuel resources and their importance. Apart from that, we will also study the characteristics and uses of petroleum fractions. The final part of our discussion will be on the contributions of the petroleum and natural gas industry to the economy and the efficient ways of using the natural fuel resources. Okay, let's look at silicon compounds. Silicon is a solid non-metallic element. It is the second most abundant element after oxygen in the Earth's crust. Silicon does not occur freely in nature. It usually combines with other elements to form silicon compounds. It has a melting point of 1410 degrees Celsius. Silicon is a shiny, bluish-grey, brittle metalloid with a high melting point. It looks like a metal, but it is chemically more like a non-metal. Natural silicon compounds exist in two forms, namely silica and silicate. Silica is formed when silicon combines with oxygen, that is, silicon dioxide. Quartz, flint, and sand are examples of silica. On the other hand, silicate is formed when silicon combines chemically with oxygen and metal. Examples of silicates are asbestos, mica, and clay. Many precious stones used as ornaments are silicates, and its color depends on the metal in it. Silica and silicates are found in various forms in the Earth's crust. They are important substances and very stable. This property makes them very useful for use in various industries. Silica has been used for a long time to make glasses. Then, the development of silicon chips in the computer industry has made a big impact to it. This is due to its reliability, which is less affected by age, moisture, or vibration compared with the old-style circuits. Silicon is also a good semiconductor. It has a high melting point. That is why it is the best available semiconductor in the industry today. Electronic chips are used in computers, televisions, and various other electronic appliances. Sand has a high melting point and does not react with acids. It is the main component of glass. Glass is made of sodium silicate and calcium silicate. Sodium silicate and calcium silicate are formed when sand, sodium carbonate and limestone are heated strongly. The molten glass obtained is easily shaped into many different objects. These objects are hard, transparent, and can withstand heat and are not corroded by chemicals. Fiber optics is used as cables in communication systems such as telephones and the internet. The main component of fiber optics is silicon compounds. Sand is also used to make concrete and mortar. Clay and calcium oxide are heated at high temperatures and subjected to high pressure in a rotating oven to produce cement. Cement is largely used in the construction industry. Next, we will look at calcium compounds. Calcium is a reactive element and does not exist in a free form. Calcium is commonly found as calcium carbonate. Calcium carbonate consists of calcium, oxygen, and carbon. It is one of the many useful calcium compounds. Natural calcium carbonate exists in many forms. Some examples are calcite, chalk, marble, limestone, animal shells, teeth and bones. Now, we will study the properties of calcium carbonate. For this experiment, we will need to have a test tube, boiling tube, test tube holder, spatula, rubber stopper with delivery tube, beaker, retort stand, Bunsen burner, lighter, marble chips, which is calcium carbonate, lime water, dilute hydrochloric acid, dropper, and distilled water. This experiment can be divided into 3 parts. In our first part, we'll test the calcium's solubility in water. We'll need to use a spatula of marble chips, which we'll put into a test tube. Then, add some distilled water and shake vigorously. Therefore, from this observation, we know that calcium carbonate is not soluble in water. In our second part, we'll need to test the reaction between calcium carbonate and acid. To begin this experiment, we have to put in some dilute hydrochloric acid using a dropper into a test tube containing some marble chips. Close the mouth with the rubber stopper and delivery tube and attach it to the retort stand. Pour lime water into another test tube and attach it to the other retort stand to test the gas released from the reaction. Now, we can see that the mixture of calcium carbonate and dilute hydrochloric acid releases carbon dioxide. This is shown by the change in lime water that turns chalky. The reaction formed salt, water, and carbon dioxide. In our final part of this experiment, we will see what would happen to calcium carbonate when heated. We have to use 1 spatula of marble chips. Put it inside a dry boiling tube and attach it to the retort stand. Pour lime water into another test tube and attach it to another retort stand together with the rubber stopper and delivery tube. Light the Bunsen burner and heat the marble chips strongly, and you will see the changes to the lime water. The lime water turns chalky. Upon heating, calcium carbonate changes to calcium oxide and carbon dioxide is released. Therefore, from these experiments, we can conclude that calcium carbonate is a natural compound made up of calcium, carbon, and oxygen. It does not dissolve in water, and when it mixes with hydrochloric acid, it will react to form salt, water, and carbon dioxide. Calcium carbonate reacts with hydrochloric acid to form a salt, which is calcium chloride, carbon dioxide, and water. In addition, upon heating, calcium carbonate will decompose into calcium oxide and releases carbon dioxide. Now, we will look into the formation of calcium oxide and calcium hydroxide. Quicklime or calcium oxide is formed when calcium carbonate is heated strongly. It is also used as a hydrating agent in preparing ammonia gas. Moreover, it is used to produce slaked lime and calcium carbide. Calcium carbide is used to produce acetylene gas. Slaked lime or calcium hydroxide dissolves in water and is alkaline. When a few drops of water are added to calcium oxide, effervescence occurs and heat is given off, forming calcium hydroxide. It is used to neutralize acidic soils. Calcium hydroxide is used to produce mortar for buildings, concrete plaster and chalk paint for the construction industry, and lime water, which is used in laboratories. We will conduct an experiment to study the formation of calcium oxide and calcium hydroxide. For this, we need to have distilled water, marble chips, copper wire, scissors, crucible, tongs, lighter, Bunsen burner, retort stand, and red litmus paper. First, cut a piece of copper wire. Then, tie a piece of marble chip with the copper wire and hang it to the retort stand. Light the Bunsen burner and heat the marble chip for about 2 to 3 minutes. Use the tongs and grip the marble chip. Cut the copper wire with the scissors and then place the heated marble chip into a crucible. We'll then add a few drops of distilled water and observe carefully what happens to the product. When a few drops of water is added to the residue, a vigorous reaction occurs and heat is given out. It produces a hissing sound. The calcium oxide swells and breaks up. Then, add more water. Use the red litmus paper and dip it into the crucible. Observe the color change on the litmus paper. Now, we can see that the litmus paper turns blue. This shows the presence of an alkali, which is calcium hydroxide. Calcium oxide or quicklime is formed when calcium carbonate is heated strongly. Calcium hydroxide, or commonly called slaked lime, is formed when water is added to calcium oxide. Calcium compounds have many uses. Calcium carbonate, such as limestone, can withstand the weathering process because this compound is hard and does not dissolve in water. This is the reason limestone is used to make cement, buildings, and roads. Limestone is also used to remove impurities from molten metal in the tin and iron ore industries, and also to produce quicklime. The alkaline property of slaked lime and quicklime is very useful in the treatment of sewage water. They are also used to raise the pH of acidic soil and to improve the strength of soft clay at construction sites. Marble that is hard and colorful and can withstand heat is used as floor slabs and tabletops. Natural fuels such as petroleum, natural gas and coal are formed from the fossils of plants and animals. Most of these plants and animals lived millions of years ago. These remains undergo chemical changes in the Earth's crust. The high pressure and heat from the layers of sediment slowly transform the fossils of the animals and plants into hydrocarbons. The natural fuel resources are known as fossil fuels. Petroleum and natural gas are formed from tiny organisms living in the seas. Earth movements later caused some of the land and petroleum to rise above sea level. Coal is another form of hydrocarbon. It is formed from trees, ferns, and moss that grew in swamps millions of years ago. Planktons are microscopic plants and animals that live in water. It is the most important source in the formation of petroleum and natural gas. Petroleum and natural gas were formed millions of years ago from decaying organic matter such as phytoplankton and the remains of small plants and animals. Dead plants and animals were decomposed by bacteria which acted on them. These form a layer on the seabed. Sand, mud, and sediment were deposited and this thickened the layer. Bacterial action on the organic remains and minerals resulted in the formation of petroleum and natural gas. Underneath the increasingly thick layers, the remains were hardened by high temperature and high pressure. Petroleum is usually found trapped between shale rock layers during the movement of the Earth's crust. Natural gas is usually found above it. Let's discuss the characteristics and uses of petroleum fractions. Crude petroleum contains many types of hydrocarbons mixed together. As different hydrocarbons have different boiling points, they can be separated into various components called fractions. This process is called fractional distillation. Fractional distillation is carried out by heating unprocessed petroleum in a furnace at 400 degrees Celsius in an oil refinery. The mixture of liquid and hot vapor is channeled through a fractionating column which separates, cools and condenses the petroleum fractions. Each and every petroleum fraction has its own characteristics and uses. The characteristics of the fraction or distillate is related to its boiling point. The higher the boiling point, the darker its color and the more viscous it becomes. It is less flammable and the quantity of soot formed also increases. Petroleum gas has the lowest boiling points. It is the first to condense, followed by petrol or gasoline, then naphtha, kerosene, diesel oil, lubricating oil, fuel oil, and lastly, bitumen. The other fractions of petroleum condense at higher temperatures. The petroleum industry in Malaysia began in Sarawak, where the first oil well was opened in Miri in 1910. The petroleum industry then quickly rose to become the mainstream of the nation's economy. This discovery of offshore oil fields in Sabah, Sarawak and Terengganu has made Malaysia a net producer of petroleum. Associated with the discovery of these offshore oil fields are large areas of natural gas. Malaysia's crude oil is of high quality, light and low in sulfur content. Thus, it is in great demand in the world market. At present, the petroleum sector is the biggest contributor to the economic development of our country. The petroleum industry not only provides the country with income in terms of taxes, royalties and dividends, it also provides more job opportunities and has afforded us with high living standards. Our nation Malaysia is a truly blessed country with abundant natural resources from silica and silicates to tin, gold, forestry products, natural gas and petroleum. We are indeed fortunate that these resources have been utilized to generate employment, wealth and prosperity for all Malaysians. And we also hope that these resources will be used wisely and efficiently so that the future generation can continue to benefit from these non-renewable resources.